Thanks everybody for joining a framework for ransomware resilience, a joint webinar by Varonis and Panzura. My name is Glenn Schock. I'm the VP of Alliances at Panzura, and with me I have David Gibson.
Hi, Glenn. Thanks so much for having me.
Thanks
you everybody for joining.
From Panzura as well, who's my know-it-all on security.
Hello. I do have some background in security and hybrid cloud storage, you name it.
All right, so we'll just kick this right off with what exactly does Varonis do, and I'll pass it over to David Gibson.
Sure. Thanks, Glenn. For those of you that are new to Varonis, we've been really following the data. I started with Varonis in 2006 when we had support for Windows and the CIF side of NAS, and then we've added support over the years for Unix, SharePoint on-prem, Exchange on-prem, 365, as well as the infrastructure that kind of supports those data stores. And recently we've added support for cloud infrastructure and data stores as well, and SaaS apps. But in general, what we're able to do is understand a lot about the data that is sitting in these platforms. So who can access the data, who does access the data, what's important, and really start to baseline normal usage, see where people have access to too much data, automatically lock that down, and of course, identify data that is subject to regulations, and then identify where that's exposed, lock that down, make sure the right people have access to it, and watch how it's being used so that we can detect breaches. So really, it's one platform that harnesses a lot of metadata about data that's sitting on this infrastructure that enables people to lock data down, kind of the data protection use case, detect and respond to threats very efficiently because we do have that knowledge about data, as well as simplify compliance. All this is done in an automated fashion, and that's really Varonis in a nutshell. Happy to dive into any of that if anybody has any questions.
And if you do have questions, please feel free to ask them in real time. We have a questions window. It is being monitored by the three of us as well as the other panelists from Varonis and Panzura, and we'll attempt to answer them in real time as long as they're pertinent to what we're talking about. Otherwise, we're going to save about 10 minutes on the back end for some Q&A. And then what does Panzura do? Panzura is a global file system that transforms cloud object storage into a very high performance file system. And the goal of the Panzura GFS is to get your data in real time available to as many points around the globe as possible. So no matter where your users are, they can see exactly the same data set. The magic in our global file system is within how we handle locking. Personally, I've been in the storage industry for about 25 years, and I've never seen, prior to Panzura, an enterprise class global file system that has phenomenal performance that honestly doesn't corrupt data, right? So it's been tried and failed many times by many different vendors. And the secret sauce within Panzura is how we handle automatic global file locking, how we pass the locks very conservatively between the various filers, how we handle immediate consistency. No matter how many sites you have, we have customers with over 100 locations that all see the exact same metadata in all locations in under a minute. And again, if you're going to replace traditional local NAS with a global file system, it has to give that same kind of performance at the edge like traditional NAS, and that's exactly what Panzura does. If you want to learn more about Panzura, we have other webinars on the subject. You can also reach out to Dana or myself or anybody at Panzura to talk about the global file system. What are we here to talk about? We want to talk about an architecture for ransomware resilience. So what we're going to go through in the rest of this webinar is talk about what Varonis and Panzura can do within an architecture that looks like this to protect your enterprise against ransomware. Let me give an example of the kind of protection that we offer. There are many articles out there about folks that have been hit with ransomware, but I want to give one example of a hospital. And this hospital was hit with ransomware, traditional method. A client got infected, somebody's laptop got infected, and it hit the environment and it encrypted their storage. But prior to encryption of the storage, that ransomware also read out all of the patient records and pushed them outside of the enterprise. These hackers, what they then proceeded to do was send a ransom to the hospital itself to say, if you want your storage decrypted, send Bitcoin to this location. But above and beyond that, they hit every single one of the patient records. When there's an email in that patient record, they sent a ransom to every individual patient of that healthcare institution and said, if you don't pay a ransom, we're going to make public your information, your medical information. So they not only hit the enterprise, but they hit the users of that that enterprise, in this case, patients. So there's two components to being resilient to ransomware. There is making sure the data doesn't leave the building, and then there's recovery of the data if you get encrypted. And what we're going to go through so that we don't give you death by PowerPoint is basically this slide and talking about the client, the server, what happens if they're attacked, what happens if the Panzura filers that are sitting on premises or in the cloud get attacked, and then what happens if your storage gets attacked either from the front or from the back. And by the back, I mean straight through the console of your cloud provider from an internal bad actor. So if my other counterparts don't have anything to add to that, we're going to kick this right off. So clients, what happens if your client gets attacked? I'm going to let David respond to this.
Sure. So I think some of the stuff you mentioned there, Glenn, about what attackers are doing, we're seeing them spend a lot of time in the environment before they start encrypting, and they're exfiltrating data before they let you know they're there. So one of the interesting concepts that I think people haven't always realized is the average employee, when they plug in their laptop on the first day, has access to way more files than they need. Glenn, Dana, what's your guess on how many files the average employee has access to?
Well, my company as a VP gives me access to about 6 since I'm in the sales organization. Probably more than that.
Well, if he has access to 6, I only have access to 5.
That's interesting. So when we do a risk assessment, we come in, we kind of analyze the permissions on all the backend data stores. The average user has access to about 17 million files, most of which they don't need. And this is kind of what we call the blast radius. If one user gets compromised, what could they access? What could they potentially encrypt? And so we'll talk a little bit about how we kind of reduce that blast radius from where the data lives perspective. But on the client side, because of really this activity is generally more stealthy than it used to be with like the early versions of ransomware, it's important to pick up signs of intrusion early on. So without putting an agent on the endpoint, Varonis is monitoring signals from DNS, from web proxy, from Active Directory that can detect when a command and control communication channel has been opened, when somebody's doing stealthy reconnaissance with reverse DNS lookups, for example. Often, an attacker, if by compromising one machine can access 17 million files, they may not need to do very much. But more frequently, what we're finding that they do is exploit weaknesses in Active Directory, like doing common attacks like Kerberoasting and things like that, to get access to broader accounts that have more privileges, keep moving laterally, access other systems and infrastructure to get really a bigger foothold in the environment before they start encrypting and before they send that ransom note. So being able to detect some of these early signs of compromise through baselining how people normally use DNS, web, Active Directory is how Varonis is helping to detect early signs of compromise without running anything on the endpoint.
Very cool. I heard an interesting story about basically somebody finding an iPhone cable at a Starbucks and plugging it in. And it turns out that that was the source of the ransomware, because folks are actually changing the USB side, putting a little chip in there. And as soon as you plug it in and plug it into your iPhone on your Mac, everything is fine and everything's great. You don't notice anything. They don't infect the Mac at all. But as soon as you connect to a VPN and that ransomware then sees, or malware then sees, a whole network out there, it starts cruising. So for the 45 folks that are on this call right now, if you've learned nothing else, don't pick up free iPhone charging cables from random Starbucks or coffee shops. Everyone's smart enough not to click on a weird link that comes in through SMS or an email. But I'm telling you, the money behind this, yeah, they're giving you a free $15 cable, but then they're charging your company several $1 million to decrypt everything. So it's highly profitable.
Yeah, it's interesting. Taking off on that, they've expanded the pyramid of basic needs now from like food and shelter, et cetera, to include Wi-Fi and battery. And people are so desperate for battery life that even these chargers that you plug into, like at the airport, there was somebody that did an attack, kind of a pen testing exercise, and that's how they got in. They kind of put these chargers out there that had the same idea.
That's funny. Maslow's hierarchy of needs is no longer
exactly
Wi-Fi and battery.
Exactly.
That's amazing. Dana, do you want to talk about what Panzura Data Services can do on the client side?
Sure, absolutely. Veranas integrates with Panzura and that's really great to help alert abnormal user activity in the Panzura global file system. So we have this PDS tool, Panzura Data Services, that's very powerful. It's a software as a service data management solution that provides you a unified management of the global file system, both on premises and the cloud edge. So typically when there is an indication of compromise, the initial access to a company's data happens at the client user level. It's growing more through other means at the server level, but still we have millions of Windows stations out there and users email phishing and all numerous ways to steal credentials. So if you get an alert of this kind of user behavior from Varonis, you may also get an alert from Panzura data services through tracking and auditing. And you can track that user's activity through the global file system like file, directory, or permission touch points. And you can pull all this information up instantaneously. It's really amazing fast. Recently, one search that we did, it was a wildcard search. So you would normally think that would take minutes for that to come up. We were able to provide 800,000 results instantly. So it's super fast, super powerful portal that can reach the entire cloud network, and it fully integrates with the Panzera file system.
All right, now on the server side.
So this is really where I think that the blast radius concept comes in. Most of the data that people have access to inadvertently comes from folders that are open to everybody in the company. When we go in and we do a risk assessment, we see typically 20% of an organization's folders are open to a global access group like domain users, authenticated users, everyone, guests, things like that. And most of those folders really shouldn't be configured that way. And there are thousands of sensitive files and many more, tens of sensitive records within those files that are exposed to everyone in the company. So think about this from an attacker's perspective. They compromise one user, they don't even need to do anything other than just access the data that that user has access to and exfiltrate it, etc. So because Varonis is able to spot where data is exposed through things like global access or just very large groups, and because Varonis understands who's using that data, it actually puts those things together and it figures out where access or how access can be safely revoked for those users that don't need access to that data. So we automatically fix things like global groups, data that's exposed to everybody in the company, help people get to a zero trust or least privilege model on those data sets. At the same time, we're baselining how everybody uses data on not just the file systems, but on email, in the cloud, how they're getting there by looking at what resources they're accessing in Active Directory. If they're accessing it externally through a VPN, we see where they're coming from. If they're coming from a cloud, we see where they're coming from, what kind of place they're coming from, how they're using DNS, how they're using the web, and putting all this in what we call a peacetime profile. And we really enrich the metadata that we're collecting. For example, we're not only seeing that files are touched, we're seeing which files are sensitive, and we're seeing which devices they touch them from, what working hours, what locations, putting all that together so that we can analyze it with machine learning. And when one or more of these facets that we've analyzed and baseline deviates, we're able to detect that. Now, in the case of ransomware, especially in the encryption phase, when we see an account that we've automatically identified as a human, we automatically identify which are human service accounts, executives, and administrators. But when we see a human that's modifying files in a way that resembles ransomware and automation, then we're able to flag that very quickly. And if you want to, automatically shut that down. The idea of reducing the blast radius, detecting the threats, stopping the threats, and then also in the final phase, if you do get hit with some ransomware and some stuff is encrypted, you have a comprehensive list of everything that infected user touched or modified while they were infected. So you can make that restore process easier.
Perfect. From the Varonis side, on the clients, on the servers, the goal here is to keep the data from getting exfiltrated, from leaving the building. And Varonis is there to protect you not only in a Panzura environment, but in any environment whatsoever, right? So no matter what storage you use, although I work for Panzura, I'm purely aware that all of you folks out there, I'm sure, have other storage devices and even local storage within those servers. And they're there to make sure that that data does not leave the building. Now let's get into the Panzura side. Panzura software is essentially a filer that installs via VMDK or Hyper-V on a server or HCI gear. We're running software that's sitting on a server, and we connect to backend storage, which is an object store that generally sits in the cloud, or it can be some on-premises object storage, such as a Cloudian or an IBM iCause. And that's how we offer our services. Our Panzura filers can sit on premises. They can also sit in the cloud. Pick your favorite cloud vendor. That can be installed via an AWS, via an AMI through the marketplace, or in GCP or in Azure. But we are looking at this from the perspective of compromise is all the same thing, right? We are essentially a VM sitting on a server somewhere in a data center, and that server itself can be compromised. So let's go through every single scenario that I can think of, and if you can think of more, again, shoot us a question on how that server can be compromised, and then we're going to talk about how the actual storage can be compromised. So if I was an attacker, how do I go after the server itself? Well, we go after the server itself by hitting the hypervisor, by encrypting the server that the Panzura filer is actually sitting on. So let's use location A as an example. Let's say that the server that this primary Panzura filer is sitting on gets encrypted itself. What happens? And the server goes down. We have two concepts of high availability. We have what's called a local HA. And local HA is exactly the server underneath. We're assuming that that server is a different machine in this case because the whole machine was encrypted with ransomware somehow for the primary and it took it down. The second one comes up, it takes over the IP addresses, everything else, all of the clients and the servers that were attaching to the top one will now attach to the bottom one. You have experienced little to no downtime from that perspective. Let's say that location A is fully compromised. What happens in that case? So the way global file systems work, if they work well, is that they have to handle file locking very intelligently. And the way that the Panzura filer works is it does just that, and it's very conservative, so that the last Panzura filer that did a write operation on an individual file holds the lock for that file. And let's say when a filer in location B, a user in location B, wants to open that same file up for read and write, the filer in location B will talk out of band to location A and ask for the write lock and then get the deltas either from location A or egress them from the cloud. So that means that location A has write locks and has a lot of write locks for a lot of the files within the global file system. If location A is entirely compromised and both of these servers' hypervisors are taken down and encrypted, what are you going to do? Well, Panzura has the concept of a global HA node. So a global HA node is a filer sitting in any location, location B, in the cloud, somewhere else, that can then take over all of the write locks that were held in location A, so that your entire global file system doesn't go down because one location went down, or a portion of it doesn't go down and become read-only because everyone else can't get access to the write lock. So a local HA will help with local failure. A global HA node is there to assist with entire location failure so that the rest of the locations have access to the write locks of the failed location. Now that your GFS is up and running, everybody's happy. What are we going to do about location A? The whole thing is down. To recover the Panzura file system in location A, let's say that you've swept everything, the ransomware is gone, life is good again. All you have to do is reinstall it via a VMDK, Hyper-V, get that software on the filer, connect it to the backend object store, and it will bring back its personality. Notice that you have lost no data. It takes a couple minutes for local failover to happen, just with ARP cache refreshes and all the other stuff, IP address failovers, all that. It would take 10 minutes for you to reinstall the software, get that software back on a VM, and then connect it to the backend object store. And again, the presumption here in this failure scenario is that the servers themselves that the filer was sitting on was compromised. If the server itself is compromised and they didn't hit the file system yet, and I'll get to that in a minute, then the recovery time is either a minute to fail over to the secondary HA or 10 minutes or so, it's a rounding number, depending on how long you can install the software, and then connect it to the backend object store. And the key here is that you've experienced no data loss in this scenario. Unless there's any questions or Dana wants to say anything, I will keep on trucking.
Sure, I wouldn't mind saying that PDS can certainly pull up all that global file system activity of that user by owner, by file range, by file size, or even a specific date range. So we can provide customized options for you to do that as well. What's really cool is we have deep analytics to reveal how your storage footprint is doing and how it's changing and who's causing it. fact, one tactic that I've seen adversaries use is they can execute malicious content by creating system services or even editing, modifying them. So that non-admin user's activity can, if it's connected to the global file system, can certainly be traced and tracked of all the files, all the directories, any permissions changed, all that activity can be tracked with Panzera data services.
Cool. We do have some questions. Is there any latency impact during global HA? So the failover for global HA is done by an admin. We don't want to make, what we want to ensure is that just because we lost a few pings, that location A isn't taken down automatically just due to some network failure, temporary network failure. So an admin needs to go in and say, okay, this is now the global HA, and it takes all the right locks for location A, wherever that Panzera file is sitting. There is no cost associated, by the way, with having a global HA node. We don't charge for that sort of thing. The only cost associated is whatever hardware you put it on, or if it's sitting in the cloud, the IaaS cost associated. All of the Panzera filers have a global sense of the metadata, so they know who's got the lock. So basically, once an admin points to the global HA node, then all the other locations will go to that global HA node for the locks from location A. So the latency is however long it took an admin to fail it over. And how many local and global HA nodes can you have? Again, since we don't charge for it, it only makes sense to have a local HA node, one in each location, just because you have hardware associated with that. There's a hardware cost associated with it. And then we recommend for our clients to have a single global HA node, because that thing is just sitting there waiting for the ultimate of failures, and we don't want you to incur costs that you don't need to incur, but you can bring up whatever you want if you just want them sitting around there. But the perfect failure scenario, quite honestly, is to have a single local HA in every location, and then have a single global HA node supporting everything within your environment. If things have gotten worse than that, you're really having a bad day. Can you do data tiering? Yes, we support all the data tiering. On the back end object stores, we do support automatic data tiering for all the cloud providers. The only thing that we can't tier to is to tape in any way, shape, or form, a la Amazon Glacier or something like that. We need it sitting on spinning disk just so the file system doesn't time out in the request. And we've tested tiering across all the cloud providers. Usually they have 3 tiers before they hit tape. So we cut it off at that 3rd tier. And that just saves you cost. The file system actually doesn't see anything. And we've had our customers turn on automatic tiering as soon as it was supported in Azure and AWS and all that, and just hit a button, automatic tier, and our file system doesn't actually notice any of that. How does a user get to a global HA? Okay, so the user doesn't get to a global HA node. Okay, that's important. The question is, how does a user get to a global HA filer once it takes over for a failed cloud filer? So the only time a global HA node is needed is by the other filers. It's just for metadata. So again, location A is gone in this scenario. So the primary is gone, the secondary is gone. You have a fire, you have a flood, you have encryption, you have something that happened that took down location A altogether. These location A filers had metadata about the write locks in location A. If somebody in location B wanted to open a file that the last write lock was held in location A, they wouldn't be able to open it for read and for write without that lock transferring. So this is about supporting location B. This is about supporting everybody else in all the cloud areas or anywhere else in this supposed environment. Location A is gone and unusable because it was, underwater or something. So the point of a global HA node is that location B can hit the global HA node, and a client location B can say, hey, I want to open up this file for read and for write. The last lock was held in location A, which is now gone. I'm going to now talk to the global HA node and get the write lock. And then that write lock will move to location B. Eventually, that global HA node will be stripped of all of its locks. As long as all the files churn, it'll get stripped of all of its locks and it will not be hit. Hopefully that answers that question. If you want to go deeper into that, email me, gshok@panzura.com. All of our information will be sent out as well, but if you have any other questions, I can answer that. And in this case, Varonis, I'll let David answer that, but I don't believe you guys track the hypervisor in this failure scenario.
That's correct. It would look like any other kind of node for us. So we're limited to what we can see in Active Directory, for example. Generally, we're not running anything on a hypervisor.
Okay, so let's talk about storage. Now, there's 2 kinds of attacks that you can have on the file system itself. So again, you have an attack from the front end, and then you have attack from the back end. So the front end attack is where, again, somebody has ransomware on their client, and it just starts encrypting the file system and starts encrypting everything that it sees. And that is an attack on the front end of the file system and is going through the Panzera filer. Again, the filer itself is up. They hadn't encrypted the operating system or hypervisor or whatever, and it hits the back end storage. And your file system system is getting encrypted in real time. What does Panzura do to keep this from happening? Nothing, because that user has all the rights to encrypt all of the files. So that's very unfortunate. But the key is here, what can we do to keep it from happening? Not much, but what can we do to save you after it happens? The Panzura global file system is immutable, which means that we track deltas since the inception of the file. So I always like to give this as a very simple example. What does immutability mean and how does our file system work? Let's say I created this PowerPoint presentation, which I'm very proud of, and I drop it into the file system, and it's a 10 meg file. So from my Mac into the file system, the initial write is 10 megs in size. And as happened with this PowerPoint presentation, David wasn't very happy with it. I'm not a very good speller, and he went in and made edits. He didn't like one of my slides. He hit delete on that slide, and then he edited some other stuff, and then he hit save and sent it to me and say, what you did was garbage, but now it looks good. Okay, so what happened? That initial write was 10 megs in size. Then what happened when David deleted a slide and hit save is we saved a block delta. So the original file was there. When he hit save, he made another version of it, which is only seen by the backend. The users don't see that. And deletion of a single slide is a block delta. Hit save. And then he made changes to some of the text. Hit save again. So he made version 1, version 2, version 3 of that. So the file system on the back end, we track deltas forever for the lifetime retention of the file system, which you can set up when you originally create the file system. If you have a 5-year retention schedule, a 7-year retention schedule, a 20-year retention schedule, we will keep everything for that 20 years. And then after that, we start deleting what we call the backend snapshots, anything older than that. And you can set that however you'd like. What happens when ransomware starts encrypting the Panzura file system? That is an encryption of my 10 meg PowerPoint file. Let's say it stayed the same size with some of my own edits. It was version 3. Now ransomware hits it, and we're going to make version 4 of that file, which is a completely encrypted version of my 10 meg PowerPoint file. And when I tried to open it up prior to this webinar, I double click on the file and it says, haha, you've been hit with ransomware. Send me millions of dollars in Bitcoin. Otherwise, you won't be able to do this webinar. I say, no, I have Microsoft VSS, or I can go straight into the file system. I can right click on that file, go into properties, and I can actually look at every single incarnation of that, every single version of that file. I go to the last version, the previous one before it got encrypted. I overwrite the encrypted version, meaning I get rid of it, and now I'm back. So how does the Panzura file system help you? We help you by not losing any data. When you get encrypted, you can, at a file granular level, revert back to the previous version, the previous saved version of that file. If you have 100 encrypted files, that's fantastic. Let's say a 1 million file system. Very difficult to do file by file. So there's 2 options here. We either have Varonis, which gives an audit log of every single change, and we can automate the conversion back. We have Panzura data services, which can do search and audit as well, or we can do a whole file system reversion back. So we have individual snapshots on those files to go back, but if you lost the entire file system, you can go back to the last snapshot. It just depends on how you want to handle it. If we've had customers across the board, we've had many a customer get hit with ransomware. What we're very proud to say is none of them have paid a ransom on data sitting on Panzura. Unfortunately, some of them have paid a ransom on data not sitting on Panzura. And in one case, and this was, I have a screenshot of this at the end of this, we had a hospital using us and they were able to recover 100%, which is why they never made the news and it just says an Illinois hospital. They got lucky. An IT person not only was able to recover the file system in the way that I just talked about, but they also, because they knew that the file system was immutable, they used us as a backup target for their structured database. And the ransomware that they had not only took down the database, it took down the backups, but they were able to recover off of the Panzura filer because that's how they handled it. So effectively, we're not only immutable, but we're intelligent. We can help you recover from ransomware with our partner Varonis, which does auditing capability. And then we also have Panzura data services that can help with that functionality as well. We have many cases that we can talk about without mentioning, and we actually just did a press release on this, that our customers just call up support in the middle of ransomware attacks. We help walk you through it, how to make the file system read-only, how to shut it down, and then how to revert. And our support organization is there to help you through that process, because again, we can't really stop you from getting attacked, but we can help you not lose any data. From the front end, this is how we help you revert. From the back end, what happens if you have an unfortunate incident where your security guy that set up the original object store here in region 1 thought that a cool password would be 12345 because they were a fan of Spaceballs, the movie, and so it's a password an idiot would use on his luggage, and the person there said, okay, that would be cool, and the object store itself is hacked, meaning it's either taken down, it's wiped out, it's encrypted, and it's hit with ransomware. Panzura supports a concept of write mirroring. So from the Panzura filers, we can do a split write for cloud mirroring, and you can either take that to region 1 within, let's say, AWS, and then split that to region 2, also in AWS, so like East and West, or if you want, you can go AWS and Google or Wasabi or whatever other cloud object store you want. And if region 1 goes down, then we can connect all the Panzura filers to region 2 because that will have no effect. Because again, this is getting hit from the back. So we're taking down region 1, but region 2 is still alive. If you get hit in the object store itself, we can ensure that there is a second object store there that can support your environment. What we've just gone through is examples of failures across the board. And then Varonis also has Data Advantage, which I'll let David talk about.
Yeah, so Data Advantage Cloud, which we announced in Q2, monitors cloud applications and infrastructure. Not only can you see where people have access and what they're doing across cloud applications and infrastructure, but you can monitor for things like S3 buckets that get misconfigured and exposed publicly, and other kinds of concerns that you mentioned, configuration issues, accounts with too much access, unusual access, that sort of thing as well.
Awesome. All right, so let me run through a couple of questions that were hit. Is there a max amount of time before the file locking is resolved globally if a filer goes down for any reason? Our metadata updates are within 60 seconds across to a global HA node and to all the other filers. So as soon as the admin migrates over to a global HA node, it's immediate. They will not see any issues. What your users will see, let's say, again, region 1 went down, is they'll see this file is only openable for read only because they're unable to get a write lock. Once the admin moves all of the write locks for location A over to the global HA, they double click on the same file again, and all of a sudden they can get a write lock. It's as fast as the administrator can move that over. How do companies deal with different countries having different retention levels? So if you're talking multinational, what we call at Panzura is this is a single ring, meaning one file system with all of the filers connecting to a same object store. The way that we handle different countries because of GDPR and other various countries' versions of GDPR is we create different rings, and on different rings you can have different retention schedules. Granted, you're no longer a single true global file system, but not only because of retention times, but because of GDPR requirements, what we find is multinationals create several rings, and that also affects retention time. So that solves that problem. Do we need to have snapshots scheduled? Okay, yes, you can have scheduled snapshots like any traditional file system. But since our file system is doing those snapshots at a file level anyway, you can schedule those snapshots as often as you want. Also, because Panzura is bad at business, we don't charge you for snapshot space like every other storage vendor out there. So the only charge for all of your snapshot space is going to be in the backend object store. But keep in mind, we're doing compression, encryption, deduplication, all of those things as well. So if you have a petabyte of usable storage, you probably dedupe and compression, let's say that you're at 3/4 of a petabyte on your backend object store, but then with snapshot space in your retention schedule, you'll probably be back up into the petabyte space. But again, we're not charging you for that snapshot space, and we're helping you with dedupe and compression to lower that as well. You can schedule your snapshots for as often as you'd like. With traditional file systems, that's always a balance. So the more snapshots I have, the more space I'm eating up within that storage array, the more I'm paying for it from a capacity standpoint. Panzura, bad at business, not charging you for that. I understand we have 3 options to recover file systems. What does that process look like? Timeline and amount of effort. I'm going to answer that question at the end of this because I actually have a slide on it. What we've done here is we've completely opened the kimono on if your client gets attacked, if your server gets attacked, if you kill our filer from the front, meaning like actually take down the filer, take down the local HA node, take down the location itself, and then go after the object store itself and then encrypt that, or just take it down all all together, you see that what we've done is enabled and given you a system between Varonis and Panzura for your data not leaving the building, as well as recovering from every individual step of failure. Back in my old Cisco days, I used to say that I can create you a network where your only single point of failure is the sun. I mean, at the end of the day, that's a single point of failure for us all. Here, what we've done is created for ransomware as best as humanly possible, no single point of failure, to ensure that your data doesn't leave the building and to ensure that if you get hit, you're able to recover with no data loss and, more importantly, not pay a ransom. Oh, somebody asked me about air gapped. I would love to get into that. Please email me gshok@panzura.com. We do support an air gapped infrastructure. If I brought up that slide, every time I brought up that slide, people's heads have exploded because it's just so complicated, but it works. We are actually in ICMP, the Intelligence Community Marketplace, and C2S, which requires us to support air gap at AWS, but we also have an air gap design without being in cloud. So if you want to handle your own storage and create your own air-gapped environment, the simple answer to this is that a Panzura filer can survive without any network connectivity. So if you're doing like a ship or with intermittent satellite connectivity and you want that ship, it's a research ship and you want it on the global file system, we can support that with local caching, with pinning the data. And so in an air-gapped environment, you can bring down the network and bring it back up. It'll resync and bring down the network again. And it is entirely supported and it works really, really well. So if you have a question about that, you want to get into it, that's a whole hour-long thing on its own. GSHOK, G-SHOCK without the C, at panzura.com, and I would love to geek out with you on that. Okay, so we talked a little bit about Panzura data services. This is an example of a screenshot of that. Again, the Panzura data services, the way we can help you with automated search and audit functionality is on the GFS itself, on Panzura. We've partnered with Varonis because we're also very well aware of their capabilities to ensure that the data doesn't leave the building, which Panzura data services isn't going to help you do. And more importantly, they help you with every other kind of storage array, including storage that's sitting on the servers itself. So in a vacuum, PDS works great for searching the impact of ransomware on our GFS itself and helping you recover intelligently.
One thing that's pretty eye-opening for people, and this is a complimentary ransomware readiness assessment. We come in and within a few hours, we can take a look at your data, see where you may have permissions gaps, see where you may have Active Directory gaps that attackers might exploit. We can also look inside the contents of files to find regulated content. We have hundreds of built-in patterns that we've been iterating on since 2009 to find regulated content and put that in context with who has access to it and who's using it. And then we can start baselining unusual behavior. Usually when we do these ransomware readiness assessments, we assess both the preventive and the detective controls. We also typically find a lot of old ransom notes that people didn't know about as well. So it's a very frictionless, easy process. If you'd like to take a look at your environment through our software and see where you may have some risks that you can tighten up in advance of a ransomware attack, or see, maybe do a purple team exercise, test what you'd be able to see if you were under attack. This is part of our ransomware readiness assessment.
Perfect. We actually have a telco using us. I'm using Panzura as an MSP that it's done a third-party pen test against our software itself. We've hardened the filer itself against attack, but again, at the hypervisor point, we can't control it, right? So if we get encrypted at the server level, there's nothing we can do. And that's exactly what Varonis is, to help detect that and then help us recover as quickly as possible. One question that we had, and I cut and pasted the top from Varonis's website, that the average downtime a company experiences after ransomware attack is 21 days. That's a very long vacation, and it's very unfortunate for the company. Panzura's impact is 48 hours. Our average customer, and we have had enough ransomware attacks on our customers, is 48 hours. So we've taken 21 days of downtime to 48 hours to recover, and some have recovered in hours, and others have taken days simply because they want to run forensics and they don't want any data loss, and they go through it file by file. That's the choice of the customer, and our average sits at about 2 days. We also, on our website, if you go down to panzura.com and you go to the very, very bottom of it, we have a statement of ransomware resilience. We've had our customers ask for this because of insurance. They've been hit by their insurance companies saying, look, if you can't prove to us that you are in some way, shape, or form resilient to ransomware, then we're going to either up your premium or we're going to cancel you altogether. So we have come out with a statement of ransomware resilience that our customers can take to their insurance companies and say, look, if we get encrypted, we can recover. So there's no reason to drop our policy, and there's no reason to increase our policy. That's something that you can do. Again, it's at the very bottom of our front page of our website. If you have any questions, feel free to reach out to us directly. Personally, one of my tasks is going to every one of the insurance companies as well as the reinsurers and getting us on that list of architectures that if you have Panzura implemented, we will not drop you or we will not increase your cyber premiums. That's become a thing. And this is a screenshot of where we help the hospital recover from ransomware attack, not only in the unstructured side, the stuff sitting on Panzura, but also because they were lucky enough to have backed up their structured database to the Panzura filer. I do have a question. Can Varonis detect data exfiltration?
Yes. So one of the things, as I mentioned, we create these peacetime profiles of what data is normally accessed by each user and what data is sensitive, what data have they not touched in a while. So we pick up signals of data exfiltration even on that initial access. Hey, this user is accessing data they don't normally do. And then we're able to see by monitoring web proxy, for example, if they're sending it out or if they're sending it to a personal email account. If a service account starts accessing personal data for the first time or normal, user data and then starts accessing the internet for the first time. This is the kind of thing that we can pick up as well. Early indications that you might have something going on, either an insider threat or some kind of malware, some kind of APT or ransomware.
So as a follow-up to this webinar, we'll be sending everybody that attended a link to a white paper that Varonis and Panzura have put together that we're finalizing now. That goes into everything that we've just talked about, all the attack points, how we can help you, and even adds a MITRE attack information in there that Dana's put in. So this is a 17-page at this point white paper that goes into every possible scenario between Varonis and Panzura and how we can ensure that you can recover from ransomware. This is a big deal right now. The point of this webinar wasn't to fight you to death. This is not fear, uncertainty, and doubt. This is a certainty. At some point, your data and your environment will get hit with ransomware. It's all about how you recover from it, how quickly you recover from it, and then the data loss associated with it, being that data leaving the building or recovering from traditional backups, which may or may not help you. And that's the whole point of having this immutable file system that can help you recover file by file with no data loss. We want to thank you for attending this webinar. We're doing another one on September 1st, specific to Panzura. At 9 a.m. Join me or whoever else might be on that. And thank you for attending this.
Thanks so much.
Thanks, Dana.